Alright, here's a review of the quadratics test that's coming up this week for Algebra 2. So we were solving quadratics this unit. We start out with solving by factoring, so make sure everything's on one side before you solve by factoring. So on this first problem here, everything's already on one side, so I'll just factor out the GCF in this case, which is 2x. So if I factor out 2x, I'm left with 4x minus 3 equals 0. Then set each piece equal to 0 individually. 2x equals 0, divide by 2, so x equals 0. And over here, 4x minus 3 equals 0. You're going to add 3 to both sides, and then divide by 4, and you get x equals 3/4. Over here, I have to add 6 to both sides, so everything's on one side and 0 on the other side. And then I can solve by factoring. Two factors of positive 6 that add to negative 5 are negative 2 and negative 3. Set each one equal to those, equal to 0 and solve, and you get x equals 2 and x equals 3. Okay, then we did solve by completing the square, which we actually did last unit, but that's still on this test, so check out the other videos if you need help with that. We did solve by the quadratic formula. There it is. You just need to really plug and chug with that and split it up only if it asks you to approximate the answers or if the discriminant's a perfect square. Speaking of the discriminant, there it is. That's the discriminant. Okay, don't forget it's not the square root. It's just b squared minus 4ac. That number will tell you about the nature of the roots based on what it comes out. So if it's a positive perfect square, nature of the roots is that there's going to be 2 real because it's positive and also rational because it's a perfect square. If it's a positive non-perfect square, again 2 real because it's positive, but this time irrational because it's not a perfect square. If it's 0, the discriminant, that means there's 1 real rational root, and it gets a special name called a double root. And if it's negative, that's the overwhelming factor. That means that there are 2 imaginary roots. Now don't forget about the consequence for x-intercepts. X-intercepts are real zeros. So this one will have 2 real zeros. That means on its graph there'll be 2 x-intercepts. This one has 2 real zeros, so there'll be 2 x-intercepts. This one's only going to have 1 real, so there's only going to be 1 x-intercept, and that actually means that the vertex is on the x-axis. And this one has no real zeros or roots, so that means there'll be 0 x-intercepts when you go to graph it. Alright. How would you solve by graphing? Well, you're going to graph the quadratic they gave you, so you're going to do negative b over 2a, plug that in to get the vertex, use the table of values, and then you're going to graph it. Let's say the graph ends up looking like that. And when you look for the answers, the solutions are the x-intercepts. Of course, you'll only be able to see real solutions. But that's how you would solve by graphing. Graph it and point out where the zeros are and name what they are. If you need help with graphing, you can look at the review from the last video. Complex number operations. So simplifying square roots when there's a negative, don't forget that's just going to be using I as the fix, and then there's 2 ways to do it from here. Perfect square method or factor tree method. I'll use the perfect square method. Square root of 4 times square root of 5. 4 is the biggest perfect square that goes into 20. 2 root 5i, or you can write it as 2i root 5. Over here we're just subtracting, we're not multiplying. Don't forget on this one, look, it's just subtraction, so distribute the negative, so you get 7 minus 2i, distribute the negative, so negative 5 minus 5 and plus 8i. Combine like terms, you get 2 plus 6i. Over here we have powers of I. Don't forget, divide by 4 if the remainder is 1. The answer is I. The remainder is 2. It's negative 1. If the remainder is 3, it's negative I. If the remainder is 4, it is 1. Sorry, there is no remainder. So I to the 86, divide by 4, and you will get a remainder of 2. So that means the answer is negative 1. Over here we're going to multiply by the conjugate of the bottom to get this I out of the bottom. So I'm going to multiply the top and the bottom by the conjugate of 3 minus 5i, which is 3 plus 5i. Okay, so up top I have to actually distribute, double distributive property or FOIL. 2 times 3 is 6, 2 times 5i is 10i, 6i times 3 is 18i, and this is the mistake that usually occurs. 6i times 5i is 30i, don't forget squared. Alright, on the bottom, if I use the shortcut for multiplying conjugates, I end up with the first term squared minus the second term squared. And now I'll take care of the I squareds, which is just going to change the sign in front, so this will become a minus. and the I-squared goes away, and this will become a plus and the I-squared goes away. So clean that up, combine like terms up top. 6 minus 30 is negative 24. 10i plus 18i is 28i, and on the bottom you get 34. And if you check out all three of these, they have something in common. What is that? It is 2, so I can divide that out of all of them, and I get negative 12 plus 14i over 17. Over here we have I in the denominator, but it's just, if you will, a monomial, a single term. So I'm going to multiply by I over I. Now up top here, be careful because this is a distributive property. So up top you get 2i minus, plus 3i squared over 5i squared. Take care of the I squareds, that makes this negative. Changes this to a minus. So I just got to clean this up a little bit. I got to bring this negative upstairs. So that's going to make this negative and this positive. So you get negative 2i plus 3 over 5, and then just flip them around so they're in the proper order up top. Alright, and the last thing on the test is vertical motion. Remember, this is just reapplying things you've already done before. They'll give you a function that models the vertical motion. T is time, and the output is height. So on the graph then, if they're asking about the highest point, that happens at the vertex. The x-coordinate of the vertex is how much time it takes to get to the highest point. Just do negative b over 2a. The y-coordinate is how high it goes. You just take the x and plug it in to get the y. Then they might ask questions like, when does it hit the ground, or how long is it in the air? And that's right here. That's where it hits the x-axis. That's the ground. So to do that, set it equal to 0 and solve using the quadratic formula. So there is the test in a nutshell. Good luck.